Hello, everyone. Hello, people. If you are, just to confirm that I'm live, you can type a comment. You can say yes or plus one, anything. Please just confirm that I'm live. Yes. Hello. Hello, Ajay. All right. So we will be beginning the session soon. Let's just wait for some more people to join in. Hello, everyone. Hello, Piyush. Hello, Gajendra. All right. So, okay, enough audience is there. People just tell me, do you know that what we are doing here? Like, do you know about the session? What part of series it is? Okay, during the explanation, I would include Hindi as well. Don't worry. Okay, so let me just keep it clear. Everyone, we are having a 21 days habit builder session in which, for a straight 21 days, we are coming live daily. So to take up some problems and to solve with you guys, we have made a list of problems which is completely in sync with the classic DSA should be. All right. So one thing more, whosoever has been attending the series, they can just write plus one now, so that I know everybody who has been regular. Okay, that count will keep on coming. Today, what we'll be doing is we'll be discussing backtracking. All right, it is a very crucial topic, and it requires a good level of understanding of recursion. All right, so it's good to see that people are being consistent and they are attending this regularly. Also, let me introduce myself. I'm Devashish Khare. I'm a DSA mentor here at GFG, and this is the first time that I'm having this lecture in this series. Till now, majorly Siddharth and Yash were having the sessions. So for today and for some of the more coming days, I'd be here to discuss recursion and backtracking. Okay. For this lecture to begin and for all the questions that we're going to do, you need to tell me that what level of clarity do you have in recursion? If I ask everybody who is here, who is attending live, to rate themselves in five, just what score would you give to yourself in the level of understanding of recursion from five? Everyone, keep it clear and honest. How would you rate yourself out of five in recursion? I'm waiting. All right. All right. Okay. Okay. Srinivasan is saying four. Good. Okay. Any query that you guys have regarding the session or what it is going to be? Anyone who has joined today only and is not following up the series, they can put up their questions here as well. I'm happy to take up from the chats if that makes sense. Okay. All right. So people have said majorly people have said three. Then we also have some of the people who are well comfortable and they are giving themselves four. Some of the people are less confident and they are giving themselves two. All right. No worries. In this lecture, I'm going to be picking up questions which are basically, which will give you a very clear understanding of backtracking. These are some of the very classical questions of backtracking. All right. To begin with, I'm going to be also telling you how the recursion is working. Don't worry about that. And hopefully, we'll be understanding everything. Okay. For the session to begin, everyone, if you don't have any queries, I'll be beginning the session. You can type yes or just Y in the comment so that I'll be beginning this session if major of the people are ready. One of the thing more that it is good if you have one pen and paper by your side and you are attending from a laptop so that you can, along with me, you can also attempt the questions. All right. Okay. Thanks. All right. Let's start. Okay, so let me give you the link of the first question. Just give me a second. I'll fetch it for you. All right. So this is the first question that we are going to be solving today. Go to this problem, read it. I'm going to be giving you 2 minutes. I'll be holding it for 2 minutes. Give it a read and try to think it through. Then I will again give you a little more understanding of it. Don't worry. We are going to revise it. Go read the question. Yes, it will say. But still, I would want you to attend the live and do the problems here so that you can ask your doubts straight ahead. All right. People, is the question opening? The session is about backtracking. Okay, so everybody who has been consistent and who is just solving all the questions, tell me once if the question has opened and you have started reading it. It's all right. Great. All right. Once you, okay, if you have read your question, let me discuss it with you guys. All right. Is my screen visible to everyone? Just confirm. Please confirm if my screen is visible. All right. Got that. Okay. So let me read the question for you guys. And okay, what the question says. The question is saying, given a string S containing only digits, your task is to complete the function generate IP, which returns a vector containing all the possible combination of valid IP address, and it takes only a string S as its only argument. That's all. Order doesn't matter. A valid IP address must be in the form of one value dot second value dot third value dot fourth value, where all these values range from 0 to 225. Okay, and the number cannot be prefixed with 0 unless they are 0. Let us understand this question in a more succinct manner. Let me share another screen with you. I am watching your comments here on the other screen. So any question that you want to ask, you can put up here. I'll be happy to answer that. Just give me a second. Let's present the other screen. Okay. Is the writing pad on the screen visible to you? Okay, it's a all right, guys. So I have taken a sample string. I've taken two sample strings here, which you will be given as an input. Okay. The question says that the only input that you will be given will be will be this S. That is one string, and it will contain these numerical values. Right. What we have to do is we have to figure out that if these strings can make up IP addresses. Okay. And we need to return all the possible IP addresses out. All right. So let's see what is an IP address first. Just give me a second. Okay. So I've written something here, right? We know that IP address consists of four values, right? We have one, two, three, four values. Each are separated by dot, just like I've written here. So for the first value and second and third and fourth, there is some range fixed, correct? So every value could be from 0 to 255, okay? And that follows for all. Now the thing is that there was also one note was present there. No value should be prefixed by 0. So that if I say 1.05.7.6, if I give this number, it is not going to be a valid IP address because we have this prefixing 0. The correct thing would be 1576. This one. Okay. And the only way 0 can be in the IP address, it could be individual. So if I'm writing 0, 0, 0.0.0.0.0, it is also a valid IP address. I hope you have understood this question so far. Just type yes sir or plus one, anything in the charts. Okay. Any doubt till now? Any doubt in the question? Because now we're going to solve the question. Great. Okay. If you have any doubt, you can put it in the charts. Okay. So what we need to do is, assuming, let's take this as our first input. So we have 2, 5, 0, 1, 1, 2, 5, 5, 2, 5, 5. Okay. Now we know two things. Now we are well aware of recursion. Okay. We are well aware of recursion. What happens in recursion is you take care of one step and then you call recursion upon the other steps. Correct? Where is recursion used? Whenever there is a problem, and that can be broken down into simpler sub problems of of the lesser size at the same time. Okay, so if I say something like, um, assuming this diagram is here, if I say that I can calculate this first value and I will call upon the recursion for all the other values, will it be done? Will it be done? Okay. So what we have to do is we just have to do that. We need to take care of this first value and then recursion will be taking care of all the other. And we need to give recursion a base case that will tell it when to stop. Correct? So obviously we would need a function for it, right? Now we need to think of all the parameters that a function may require. The first thing is going to be your string itself. So we can say, yes, it requires a string, correct? The second thing, we need to traverse this string, right? We need to go in this string like this and need to check on every element. For that, we require one index, one variable to keep track of index. So it could be one of the variables. And the next parameter could be what could be the next parameter? We want to know the length of this string for the base case, because we need to in the base case we need to specify if the I has reached the end, we need to stop, right? So for that we also need this n for keeping the track of that. Now we are thinking of designing our function in such a way that we are working for this one, right? We are working for this one, and when we are not talking about all these three, but still the partition of the question is going to be in this manner. So for that we can say uh, this first chunk we can call it a level. Okay, so we can say that the next parameter here is level. Okay, we'll take care of the first level and we will ask the recursion to take care of all the other levels. Right. Now, the last parameter could be, or let's see how many parameter it takes. One parameter could be a string in which we are building our answer. Okay, so we can say it as a temporary string, or we can say a result string. Up to you. You can name it anything. I'm saying it to be a temporary string, which will be calculating my answer. Okay, and once a whole answer is generated, I am going to insert it in another list, and let's name it as answer. Okay. So what I'm going to do is I'm going to create one list answer which will be returned as the final answer to the function. Okay. What I have to put in inside this list? All the possible strings. Okay. Make it like this. All the possible strings, all the possible IP addresses. I need to put in this answer list. Correct? Are all the parameters clear till now? In the charts, come on. Are all the parameters clear till here? Okay. Now what do we need to do? We need to think of a logic. Correct? We need to take care of the restrictions. We need to think of a logic. That those are the only two things we need to do. Correct? In recursion, what usually used to happen, we were making just a single recursive call. Correct? Or even if we did some more questions, we made two calls major. But in backtracking, we are going to be having number of options. Okay? We will see the concept of backtracking along with this question. Don't worry. But in brief, I would want to tell, if you want to detect that a question is requiring you to solve for all possible paths, for or you can say all possible ways, then there is one all possible keyword is there, right? So you can get a hint that that we can use backtracking. Okay, that is a key. Now for this particular question, what we are going to do is, it is just recursion, but we are going to just get a one level up a notch. That's all. So we do have our list. Okay. So assuming we are designing a function here, we will take care of the base case later. Don't worry. Now let's work on the logic and the function calls parts. Okay. So the very first thing is we will be seeing that if whatsoever s your string is coming, if that is zero, we're talking about this, right? We're talking about that, and we are making first level of our IP address. We need to make that. The first possible way could be that if we have zero, correct? We need to check that. Let me change that. Okay. Okay. Assuming this green arrow is my ith index. Okay, my I is currently zero. This is the initial place. What I would want to check is I'll check if my SI, okay, if that is zero, I'll check that. If that is zero, I'm checking for the condition in which we do not have to make a call. Okay. So this could be a condition along with if len of the temp is a solution that we have created so far and we created. Or let's define, we say for the string till now. Or we can say that, okay, we are talking about this string. So we will make yet another variable. Let's call it ad, not variable. We will say that we are keeping a chunk of till I and I plus 1. Okay, we are keeping this chunk from I to I plus 1. That basically means we are just talking about 2. But let's say we are talking in this manner. Okay, so length of this AD, if that is greater than 1, right? If len of this AD is greater than 1, what would it mean? If length of this AD is greater than 1, then assume you have 25. Okay, and you're checking the first value of that. If that is 0, that means we are not going to call it. So if I'm having 0.5 as you can say preferable value for one level, it will won't be counted. It will won't. This is not a value we are going to be proceeding with because it has one preceding 0. We are checking this condition. All right. The other condition could be if the slice that I have taken, because I'm going to be taking 3 slices, because those are the possible ways that I can fill the first level, right? We have the range of 0 to 225. That means we can take 3 digits. So we'll be taking three slices. First for the first one, second, and the third, right? So the next condition could be we will typecast it to integer. We'll say what is the integer value of this added string, and we'll compare if it is greater than 255, then also it is not allowed, correct? So in these conditions, we will simply return. We won't make any calls. But if this happens, and then we have to make a call after it, what will we do? We will say s is going to go as it is. Correct? I'm saying I plus 1. I'm considering 2 right now to be my first level of this IP address. So I'll set I plus 1. That indicates now this string is to be worked upon further. Correct? Then I would say that the next was n. N is going to go as it is because we are talking about the initial size of the string. In this, we will, using this, we will create a base class. Okay. Also, now talking about the level will be increased because now I'm keeping only 2 as the initial value. And I am saying that the first level is done. Now go take care of the other levels. I am asking this to recursion. Okay. Once this has happened, we need to build up this temporary string. We need to build up this temporary string so that it contains an answer. Right now, what do I have? I have 2 and this dot which I want. What we can think of it initially, and it would make our function calling easy. We will initially take one empty string, and in every call, what I'll do is I will say whatsoever the temporary string was. Initially, it was, you can say, empty. Add a dot to it. Okay, add a dot to it because this requires, we want to make it in the form of an IP address. Add a dot to it and then add this AD value. Okay, this will make up nothing, blank string or dot 25. And in the next iteration, we will again have dot in front. So the temporary string would something, okay, the screen has gotten a little messier. I'm going to clean it. Just see where I'm writing. So what the string is going to be something like 2, 5, assuming it to be initial, dot in front and dot in back, and then some other value, and then dot, and then some other value, and then again dot, and then some other value. This will be temporary string. I'll just chop it down. I'll remove the first one, and that will be our IP address. Okay. All right. And the last parameter is going to be the answer itself. Answer means in this list, finally, I'll be adding up my temporary string once it is completely made. Once our IP address is completely made, and that will be done in the base case. Okay, till here, tell me if you guys have any doubts, if anything is not clear, because after this, we are just going to be having a little more of one node illustrations, and then we will jump into the okay. Any doubts, any queries? If you have understood, just say yes or plus one, anything. Hmm. I'm waiting for your questions in the chats. Okay. Okay. I have not yet come to the base case. We are going to do that. Don't worry. Okay. All right. Let's talk about the conditions first. The first possibility could be this: when we are just making up first value. Okay. Level plus one, temp dot, temp plus your dot and your add a string and the answer, right? Now the thing is, this is if we are considering the value to be 2. Okay, just copy this. Okay, assuming this to be the string. This is the function call when we are considering this. Okay, but that is not the only possible thing that we have to do. We need to take 3 steps, correct? Because we have a 3-digit word to a 3-digit number to form. Then we'll take this string and we will say, go see this if this is possible. The third would be 250, correct? And all the further levels. We have to make the level 1, and these are the 3 possible ways we can make the level 1. For that, some of the parameters are going to be changing. It is going to be like that. I will be changed to I plus 2 because now we are not calling from here, we are calling from, we have covered these two, we are calling from here. Okay, then I will be plus 2 and is going to remain as it is. Level is just increasing by 1 because this is the another choice we are making for the first level. We are calling the function on the second level. Again, this thing is going to be same because now our add string is this, right? And eventually answer is going to remain the same. For the third one, if we are considering 3 values, s I plus 3 n same everything. Till now, make it an open conversation. Wherever you feel you are finding it hard to understand, you can you can put it in the chats. I'm constantly seeing the chats. Don't worry. And I know if it is if it is for the first time that you are learning backtracking, it might be a little tough for you. But don't worry, I'm here to take your doubts. Okay. So these are the 3 possible calls that we have to make. Yes, we'll be making it. Now let's talk about the base condition. If we have made these 3 recursive calls, what could be the base case? We need to check if first of all I is equals to n, correct? That means our iteration that we are what we can say our traversal that we are doing through recursion with the index I has come to an end, that we have reached the last point at that case, and we have completed all our 4 levels. We are done with the level 1, 2, 3, and 4. Now the level has become 5. If this is the case, that means we have one answer completed. Okay, that means we have one IP address completely made inside 10. At this case, what we will do, we will say answer dot append. Okay, that means I'm just pushing it inside the list, and I can write 10. All right. Have you understood this so far? All right. Okay. Pratik, you have understood. Everybody else, just write +1 if you have understood till now, so we can jump to code. Okay, I'm beginning coding, right? Yes. Okay. Here we have the function. Well, nobody, this session is about backtracking, and we are just giving you a taste of how it is going to be with multiple recursive calls in this problem. And further on, for the next problems, we are going to be diving to backtracking. This is not directly backtracking, but still, we are getting there. So, we'll try one after. Okay, sure. All right. We have to construct this problem. We have to construct this code. Let's go ahead and do that. All right. The very first thing, we need one answer list, right? In which we are going to be storing everything. Then we also need the length of this string. So I'll just initially. And guys, I'm coding in Python. I hope it is okay for everyone. And then I'll say, I'll create one function. Let's name it solve. What do we need to solve? The same parameters. We wanted s, yes, it is going there. We wanted I. Initially, let's give the value to be 0 because we are moving from the first index. We want n, let's call that. We want one temporary string in which we'll be building our answer. Initially, it is going to be empty, so the initial call, I am giving the argument to be an empty string. And then an answer, right? These are all, and then after it is done, after solve has done its work, I'll simply return. Okay. Okay, one thing we can initially check, and that would be a smart thing to do. Let's quickly discard the strings which are not matching the length. Okay, we can say that if length, we've already calculated it once. Let's try it. If n is less than 4 and n or n is greater than 12. In any such condition, you can simply think in any such condition there would be no possibility of generating an IP address. If it is less than 4, not possible not possible for IP address. If it is more than 12, that means we are talking about 3 multiplied by 4. That means one of the levels is going to be exceeding the 3-digit number. That is not what we want. So at this position, we can simply return. Let's simply return an empty list. Okay. So now we have to design our solve. Let's design the solve function. Okay. So for our solve, the parameters that we are picking, let's name them. We want s, we want I, then n is going to be as it is. I'm talking about temp. Okay. These are all the things that we need. Also, let me just go to the illustration once. Just give me a second. Okay, for that. Okay, I forgot level. I was just thinking, I'm forgetting one thing. I forgot about level. So we also have to include level. So let me just include level here. For the initial call, level is going to be 1. So let me just say 1. And here, let me receive level. Okay. Are the parameters clear to everyone? These are the very important things when it comes to making recursive calls. Are these clear to everyone? Yes, Ashutosh, in C++ you can use a vector. Okay, please just tell me if this structured code is clear to everyone till now. Now we are going to do the main thing inside the solve function. All right. So we need to make three function calls, as I told you. And what we are doing is we are taking three slices of a string. We are just taking I to I plus 1, then I to I plus 2, then I to I plus 3. These are the three slices that we are making, and then we are doing the same thing. We are seeing that if that is a possible add a string, we will make a function call. We have to do the same we have to do the same strings three times. So what we can do is we can simply use a while loop and we can mix in some variables. Let's do that. Let's just say k equals I. I'm just creating a new variable. And then I can make the function calls in an easier manner. Instead of repeating it, I'll just write it for one time. So I'll say while k is beginning from I and is less than I plus 3 because we have to make three calls, correct? And just for the safer side, we will also check that if that is not exceeding, if that is not exceeding n. All right. Now in this loop, what we have to do, we have to construct the AD string just as I told you in the dry run. What I'll do, I'll take a slice. That means from I to I plus 1. And that, okay, just for the people who do not use Python, this way we can slice up a string and just and another string will come to this AD variable and this I plus 1 is excluded. The second parameter of slicing is excluded. That means only for this case, for the initial case, when I is equals to 0, we are going to be saying s0 colon I, and only one the one value from the string is going to be sent to it. Okay. Now let's talk about the conditions. We were talking about the conditions there. What could be a suitable condition in which we have to not make the call? It was we were saying when s's initial value, when the string's initial value is initial value for the first one, okay, for the ith value, that means the chunk that we are taking, the ith value, if that is 0, correct, and the length of AD, and the length of AD is greater than 0 alone, it alone is allowed, but along with anything is not allowed. So we'll say if len of AD is greater than 1. If this is the case, then we would not be making a call. Also, there is one more thing to take care of. If my AD is still less than 225, correct? And I do have to typecast it to an integer because this is a string. So I'll say that if it is greater than 225, these are the places where we do not have to make any call. I'll simply just return. Okay. And apart from that, we need to make function calls now. What I'll do is I will say solve. Okay. And what are going to be the parameters? S is going to remain same. Correct. And next thing, we have to say like when we were making separate calls, we were saying I plus 1, I plus 2, and I plus 3. Here I'll say just simply k plus 1 because whatsoever value the k is having, according to this, we are going to be calling upon that. Correct? K plus 1. Then we want the size of the array to be passed. Then we want the level to be increased. Right? We want whatsoever level is there plus 1. We are increasing the level. Now we have to construct the string. I'll just do the same thing which I did in the illustrations. M plus dot for the separation between the level because we are ending up with this level now. And I'm just gonna say here 8. So that is combined. And answer is going to go as it is. Alright, clear till now how we are making the function calls? Any question? Also I have to increase k for the while loop. Okay, somebody has written. You're saying that. Yep. So thank you for pointing out the mistake. You have said the right thing. Let me correct it. I did that by mistake. Okay, now it is better. Okay. Thank you, Chimras. Thank you for paying attention. Any question till now? We have made the calls that we had to make. Now we just have to write the base case. Any problem, people? Any doubt that you have till now? You can say. Right. Let's write the base case. The base case is going to be my I, if my I is n that has reached n and level has reached 5. At this point, what I'm going to do, I'll believe that my recursion has run successfully and the temp is holding one IP address. I will add that to answer. I will append it to answer. Also, because initially it was a empty string and we were doing empty string plus dot the add variable. So now this time what we will do, we will remove the first first value from it because that is just a dot. I'll say from the 0th value. We do not have to do that. I'll just say from the first value till the end of the string. This is the slice that we will be passing. This means that we are just excluding the first value and we'll passing all the other things in the string. We are appending it inside the answer. Okay. Ashutosh, what you can do is you can then take care of the variables and then you can make copies and you can use the variables there. And I'm talking about the index variables. You can keep track of that and you can copy it. You do have a copy function. Yeah. Anybody? Any problem with this code? Any problem with this code? Okay, it has already taken much of our time, and this session is going to go longer than 2 hours. Let me tell you, because two very interesting problems are ahead. Everyone, please quickly respond in the chat that if they understood this problem well. Plus one, please, in the chats. Okay, it is working fine. Okay, so it does have some runtime error. We'll take care of that. People, I'm waiting for you to answer if you have understood the concept. Actually, once you understood the concept. Everybody else, please, if you have any query, you can put it in the chats as well. All right. It may require some debugging for getting that runtime error out, but I know the time is just running out. I'm going to jump into the next problem. I hope the concept of this problem is very clear to everyone because that is important for our next problem to jump in. Okay. All right, Srinivas, thanks for the suggestion. Okay, let's do that. I'm going to be putting the next link here in the chats. You've gotten the link. Go. This problem is rat and a maze, and it is a very popular problem when we talk about backtracking. This is going to be your first introduction to backtracking. All right. We have gotten comfortable. We will talk about that. Yeah. So this is going to be your starting of backtracking. We are now comfortable with making multiple calls using a loop inside our recursive function. Now let's see what we're going to do in backtracking. I'm waiting for you guys to open the problem and just read it once. I'm going to be giving you 2 minutes for that. All right, till then, Poonam, your question, when to choose backtracking, when to choose recursion only. Well, backtracking is nothing but just a modified form of recursion. Okay, it's a big brother of recursion. अब क्या होता है ना कि backtracking जब include करना है question में, then somewhere or the other in the question they would be requiring you to completely give all the possible ways, all the possible paths for something. So when this keyword comes to your mind that we need to find out all the possibilities, that means we need to use recursion. We need to use backtracking. Okay, let me tell them just for 2 minutes. Let me give you some theory. In backtracking, what do we do is it is a simple recursion, but we have some choices to make at the step that we are standing. Okay, so assume we are at a particular step. We have three choices to make. I'm just giving you an example. We have three choices to make. If we make one choice, we have a whole recursion tree, or you can say we have whole possibilities to go according to that. Okay, and there could be a possible solution line. If I get that possible solution, I will record that somewhere. Okay, and if I do not get any possible solution, I will backtrack. I will come to the step that I am standing right now. I will make some other choice. I won't make the choice that I made previously. I will make some other choice, and then I'll go in that direction. And once I have found a suitable solution there, I will record it. I will backtrack to the initial position where I'm standing right now, and I will simply just make the third decision. All the possible decisions that we can make when we are standing on a particular step, we have to make it, then we have to unmake it. Okay, for the next step to happen. This is how it goes, just in theory. Okay, so did the whatever I've said in theory had made any sense to you guys for backtracking? You can write it in the chats. All right. Okay. I hope that answered your question, Poonam. All right. I'll be beginning with this question. Vietnamese form. Actually, instead of just reading it, let's go to the illustrations directly. Okay. All right. So for making the work easier, I've already made some illustrations. Now we are going to be using it to understand what actually is database. Okay. So you will be given two inputs. First is actually the size of a matrix, and the next will be you'll be given a matrix itself. The matrix will be composing of uh, ones and zeros. Okay, just like this one here. It will be composing of ones and zeros. What does that mean? Zeros are the hurdles, and ones are the paths which are valid. Okay, what is the main motive of the question? You have to assume a rat is standing here at the top left corner, which is your 0, 0 uh, place, and you have to make it go to the last block, which is your n minus 1 n minus 1. Assuming it is this one. Okay, So this is the question. What? We have to give all the possible ways in which this rat can reach its destination. How we are going to give the ways? We need to tell that if it goes here, that means it takes a down step and then it goes towards right. It is going to take R, and then if it goes here, it will again be down, and if it goes one more down, it will be again one down. Then it goes right, and one more right, and it is reached to its position. So this is one of the possible paths. Okay, we need to give DRDDRR as a coded string. This is one of the possible paths, and we have to calculate all the possibilities because this question is asking for it, and we'll be using backtrack. Now, what I said when I was telling you about the theory of backtracking, assume if you are standing here at this position, you have two choices to make. You can either go this side, you can either go this side. If you go this side, there is a possibility that you will find a solution. If you go on the downside, there is still a possibility you will find solutions from here. So once for the first time you'll make this choice, you will find out all the answers that this choice can make. You will again come back here, and then you will make another choice. You will unmake this choice, and you will make this choice this time, and then you will proceed with all the possible paths from here. Okay, is the question clear till now? Is the question clear? Let's put in the chats very quickly because we do not need to waste time. Okay, let's put in the chats. Yes, Srinivas, it is DFS. We'll be making a choice and we will be unmaking. Okay. Everybody? All right. Yes, DFS will go. Okay. Now let's see. Okay, first let's clear about how we are going to travel in direction. I hope many of you might already know, but let me clear it for everyone. If you are standing at the center and assume you have your coordinates x comma y, you have your coordinates x comma y. Then if you want to go to this block, okay, if you want to go to this block, what you will do is you will subtract 1 from your x and you will keep your y as it is. Okay. If you want to go to this block, you will have to keep your x as it is and your y to be plus 1. What am I doing? If I have to go to this block, what I'm doing is I'm reducing one row and the column is not getting changed. If I'm moving to this block, I am remaining on the same row and my column is getting changed. So because I'm going in this direction, my column is getting plus 1, right? If I have to go down, that means my one row is increasing and the column is constant. So for that, x plus 1, the row is increased, column is as it is. For the last one, you can guess it right. The row is going to be constant and y will be reduced. For the last one, this one. All right. Is this the way that we are doing the traversal in the matrix? Is clear to you? Everyone write plus 1 again. Plus ones, please. And if there is any confusion, please write it here right now. All right. Okay. So this is done. Instead of directly jumping into the algorithm, let's do some illustrations first. See, we have to construct a string. We have to construct a string. The motive of a question is to construct a string like this. In this string, what we will do is we will add up these values, directions, and we need to keep a track of what path we are choosing. If we are going down, we need to write D to this path. If we are going right, we need to write R to this path. And eventually, if we reach the solution, if we reach n minus 1 comma n minus 1, this is our basis. If we have reached here, That means whatsoever string is constructed so far, we will record it. That means we will just make another list of answers and we will record this answer. We will append that answer. We will append this string to the main answer. Okay, is the concept clear? Let's move ahead. So we'll be designing a DFS function for it, and we'll be understanding how the DFS function will be working. And for that, you need to pay a little more attention. Okay, so if you were lagging off, just stay with me, and we are going to do it. Just for the better traversal, I will make a separate array or a tuple, you can say, for directions. I will record these directions. I'll say I'm going in 1 comma 0 comma t string. That means this is the possibility. I'm just writing these things, okay, for better understanding. I'm making a direction tuple. This could be this is a possible direction we can go in, and it is d. Another way, we have 0 comma minus 1, 0 comma minus 1. That means we have L. Okay, so the third parameter is L. I'm going to keep a record of it. Okay, the third parameter will be L. And then what we will do, we will write up, let's see, let's talk about R. 0 comma 1 would be there, and this is our R, this one. And then for just for up, because there could be a possibility we are going upside as well. So just for the sake of it, let's write -1 comma this and U here. Okay, this is a direction tuple. Is the direction tuple clear to you? Is the direction tuple clear to you? Quickly answer, please. All right, let's go ahead. Now let's make up the solution. Let's solve the design of DFS function now. What parameters would a DFS function would require? Again, we are creating a function, and DFS is way of traversing a matrix or a graph in general. It is depth first search. Because we are searching for a path, we are going deep inside in one path. So a DFS is a possible solution. So we are making this choice. For that, let's see what parameters our DFS function would require. Very first thing, because we're talking about matrix, so we need to keep a track of I and j. That means the coordinates, correct? Then the other thing would be our matrix itself. Let's say mat. Okay. Apart from these, we need to maintain one data structure to see if we are not going back, just back towards we have come from. I am going to let you understand. Okay. All right. We need to keep a track of things. That means for that we are going to be maintaining a visited data structure. What it will take, it will keep a track of all the blocks that we have already visited. So assuming you were standing here, you went here. Now for this block, a new problem starts. That means just a fresh problem here. This this block has possible ways to travel. It has this way, and if you do not maintain visited, you wouldn't know that this place is already visited. Then this place would also be considered as a possible choice, and we need to avoid that. For that, we will be making a visited array or a visited set. Anything we'll see in the code how we'll do it, but we will be creating a data structure such that it will keep a track of all the visited ones, right? And another, we will again need one. Let's say we'll call it a path, a sample string that we'll be constructing in the base case, just like we did in generate IP address. Okay, that is why I said that portion is important for him, and we'll be recording that in answer again, our list that we put to work with. Now, I believe if I write down the code of it, you're gonna get it like even in a succinct and more precise manner. Correct? So clear till now? Are all the variables that we are taking clear to you? Quickly write me up in the chats. Are all the variables clear? People, are all the variables clear to you? Let me jump to the code now. Actually, I've already written some code. Okay. Poonam, path is the string that we'll be constructing. This one, just like I show you, dr, dd, rr. Every choice that we will make, every step that we will take, we will also include that in our path because that is a possibility. Okay. So if you're going down in path, we will include down. Okay. All right. I'll be moving to code. I have the code already written, but just explaining that wouldn't make sense. I'll write it from the scratch so that it is much more clear to you, and you will also get an idea how to write a DFS code. All right. Okay. Answer will be having all the possible paths. Okay. So if we're talking about answer, it is a list of strings, and every string is a possible path. We will construct a path if it is valid, if it has made us reach till the end, till our destination, we'll include that in our answer. Else, if we are constructing a path and that is not valid in the end, we come to know, we will simply discard that. We won't include that in our answer. All right. So let's write up the question. We have find path for that in a maze, and I've covered everything that was written here. You can read it once more. I gave you time for that. Okay, so we need one answer, just like the previous question. And let's talk about a very basic case. What if the first block, that means I'm talking about the 0, comma 0. If that corner cell is already blocked, that means the rat has no place to stand. So the question wouldn't make sense. We'll include that. We'll say if M 0, 0, MC matrix and SSIs, if this is equals to 0. And what does 0 means? A blocked path. That is a blocked path. And actually, one thing I would recommend, whatsoever I'm saying here and doing the code of, you can keep on drawing that anywhere, use pen and paper, draw that, draw a matrix, and then see what I'm writing. And you can code along with me. Okay, so this case, and what if the last destination, the n comma 1, n minus 1, comma n minus 1, the place that we have to reach, if that is blocked, that means there is no way the rat can go till the destination, correct? So B will also take care of that. M n minus 1, n minus 1. This is 0. This is 0. Then what do you do? Simply say return an empty list, correct? There is no sense making call for such cases. Now, what were the variables? We needed one path variable. I'll just say that, and I'll create an empty string for that. We needed visited. I'm writing viz for making it clear. Okay, visited. I'm going to use a set here. It is easy in Python. You can also use a visited array. And then let's make the DFS call. What do we need for it? We are making the call from initial point, the first point, which is 0, comma 0. So I is also 0, j is also 0. Then we need to set the matrix. It is going to be going in the function definition every time, unchanged. Then we need a visited set to be there. Okay, then we need a visited set to be there. And apart from that, we need the answer and we need path. Okay, these are all the things that we need to make the solution for this question. And once our DFS has run successfully, we will be returning the answer. Right? This is the structure of the code. Now let's compose the function and make it do what we want it to. Right, def and dfs. Also, there is one utility that we talked about, directions. Let's construct that first. Write that first. Just give me a second so that I can write it. Creating one global tuple. So the first thing is 1 comma 0, the same values that we have talked about. That is what I am making here. Okay. And the other would be 4, 9. Next one. Has a little time to. The last one is down, which would be next one. Uh, all right. So this is done. Action is done. Took a little time for me to do that. Let's design a DFS. DFS. Let's take up the values I, comma j, comma m, comma visited. Okay. And then the next thing is in visited. Then we have answer and path. All right. That is done. Now we need to make calls. We'll again talk about the base case later. The base case, I'll tell you, it is very simple. When your ij have become n minus 1 comma n minus 1, that means we have reached a point where we wanted to. We began from 0 comma 0 and we have reached n minus 1 comma n minus 1. We have reached a destination. That means if we have reached it, a possible path is formed in the path variable. A possible string is there. We will include that in our answer. That's going to be a base case. We'll write it later. The very first thing. Now notice, this is the structure of every DFS function you write. The very first thing you do in a DFS function is you mark it visited. So let's do that. Visited. Inside visited, I'll add a I comma j. Okay. So I have to say visited dot add. Visited dot add. Inside visited, what I'll give, I'll simply give I comma j as a tuple. So I know that I comma j as a tuple, so that I know that this tuple, that this cell is visited. All right. Okay. Yeah. Again, I'm saying it again. If you have any confusion, you can put that in the chats. All right. So once you have marked it visited, then what you have to do? We have to make the function calls. Okay. For in how many directions we have to make the function call? In 4 directions we have to make the function calls. What are those directions? We have already declared that at the top, so that it won't be messier for us to call for all the DFS for all the recursive calls here. So I'll just say for it's a D in direction. I'll say that my new ij, new I comma new j. What will be the values of these? My existing I plus d0 comma j, my existing j plus d. Have you understood what I have done here? Have you understood what I have done here? Quickly, plus one in the chats. If not, say no. I will repeat that, and I'll tell you what is happening. Okay. Once we know what the new I and new j we have to go to, we will check that if that is a path which is valid. Okay, there could be one possible case as well I did not talk about. Let's take care of that. Can I illustrate it? Okay, so if you are here and this is a matrix and you are here at this block. Okay, you have 3 possible ways, 1, 2, 3. But in the direction array, you can say there is one place to go up as well. Okay, so once you go to this is actually out of your matrix, correct? This is out of a matrix, so there is no way you can go there. So we need to make a check that we are not going out of the bounds. For that, just let's make a utility function. No worries. We create one function here. I'll name it as def is valid. It's valid. I'll give the parameters to be my I, comma j to check if this block is valid or not, comma m. Right? And I'll say return and check the value of my I if that is between 0 and the len of m. Correct? If I is inside the boundary and if my j is inside the boundary, that means len. Okay, everyone. We are just checking that if that is inside the boundary or not to write up the new condition. So I'll check that if the step that I'm going to, you cannot see my explanations. All right, sorry for that. So what happened? I was actually using one marker which was displaying over the screen and one of my tab is shared. But let's just make it clear like this. I was telling you that if you are standing at a corner of a matrix and you have a possibility, if you go towards, if you take one more step, if you go towards right, let's say your matrix end, you are standing at a corner, you cannot go right further. But you take that a step, that would be out of the matrix. So to avoid that, you will check first that if the step that you are about to take is actually inside the boundary of the matrix or not. So I have made a function for that. I hope that is clear to you. Okay. I hope that is clear to you, right? That is clear to everyone, what I've done. Now let's do it quickly. I'll say is valid what my new ij, my new ij, these two values are actually inside our boundary or not. If this is a thing, and okay, we need to check that this is not the choice that we are making that we have been from. That means if we are standing at a particular cell and we have made one choice, we are not going back to that. If we have come down to one cell, we are not going again back up. For that, we need to check our visited. Now I'll check that if my new I, comma new j are in visited. If these are in visited, that means we are not going to go further. That is valid, and these are we are making the positive decisions. That means we have to say these are not in. So if this is not in visited, we will make the further calls inside this. Last condition is going to be like if we have a possibility to go in that path or not. That means we have to check that if that path we are going to, if it is one or not. Because if it is zero, that means it is blocked. Okay. So we need to check if my new ij, okay, my and my new j. Okay, if this is equal to your one, okay, this is equal to one, then only we can make the DFS call. Now only the DFS call is left. Let's make the DFS call. Okay, so for that, what are the changes? What are the changes that will be there? Instead of ij, now we are talking about the new step. We are talking about the new ij, and then I'm saying m is going to go as it is. It is a matrix. We have to pass on visited. Okay. Apart from that, we need answer. We need answer. Now the last, the path. We have to build up a path. If we are talking about the very first step, initially it is blank. We need to add up what? We need to add up one value. What it is going to be? As this that we used. It has third parameter as well. It has this third parameter as well as letters. I'm going to include that. Okay. So it is going to be path, whatsoever the path is, plus these second element. Okay. it will get keep on adding. Now once this is done, the next step is to come here, come out of all the choices that we have made. Uh, yeah, when we have made all the choices, then we are coming again. We are standing at a position, we explored one path. Then we are again coming to the again back at the same point, and we have to make another choice. Okay, that means we need to make the node that we are standing right now unvisited. Correct? Because if you keep on visiting the nodes and you're coming back, that means you need to unvisit them as well. You step on it, you say visited. You step back from it, you say unvisited, so that uh, it can be used for further possibilities as well. Okay, I hope you're understanding this. All right, I'm waiting for all the chats here. I'm seeing it. Just you can put up your queries there. Okay, feel free to put up your queries. Once this is done, let's say for this time we have to remove. We have to remove the ij. We are standing on ij. We have explored all the four parts. Now we are stepping back. Okay, we are going back from the ij. So that means we have to remove that, right? Now, okay. Is it clear so far? Is the code clear so far to you guys? Okay. One is asking one thing. All right. See, why did I add d plus 2? This is my direction array, and d is elements of these tuple, of this tuple. D will be this or this, one at a time. Okay. So assuming if we are talking about going down and we are taking this tuple, what will happen? We'll have d0 as 1, d1 as 0, and d2 as this capital letter D. Okay, so it gives the direction and that gets added to the path. All right, I hope Pratik has already answered that. Great. And all the people who are watching right now, who are solving with me right now, I hope everything is clear to them, right? Plus one in the chat, please. Plus one in the chats. All right. So Poonam, Srinivas, and Pratik are three people who are constantly doing it with me. Thanks people for supporting me. Okay. All right. Let's just. I hope everything is done, and if it is not, we'll get some error. We'll debug that. Okay. So it is working. Okay. It is working. Okay. It is giving one of these errors. Let me see. Can you find any of the error because it hasn't worked for the test case? All right. Uh, I have coded with you guys and you are paying attention. Let me help, just help me debug that. Okay, so it is giving -1. That means it is not adding up the path. Okay, I did not do the main thing. I did not write the base case. Okay, that was funny. I did not write the base case because I left it for the last. Okay, now let's write the base case. What is the base case? If if my I is equals to len of m -1 and my j is equals to that as well. And my j is equals to len of m. So eventually is going to m. And why we are uh, in the function, we are not talking about n. All right, not passing that. Okay, so I hope this works now. This is the base condition. Whenever this will hit, we have to make up the answer. We have to say answer dot append. And what do we have to append? We have to append the path. Okay, path, and then we need simply. Okay, I've written that. So if we start, all right. Thanks for the. All right. Yeah, we are getting the output. It is working fine. Poonam, you can click the snippets of it. I cannot post it anywhere. The chat won't support this logo. Okay, you can take a screenshot of it. So this question is done. Do anyone have any problem regarding this question? Stop share. All right. Before we move to the last problem of this day, does everyone uh, have a clear understanding of this question? You can write Y or yes, anything in the charts so that it is interactive. All right. Thanks, Srinivas. Thanks, Prateek. Okay, let's talk about the new question now. The next question that I'm going to give you is again a very famous problem. It is n queen problem. All right, and we are going to be solving it using again the TFS and your backtracking method. And let me give you the link of it. It's take home generally. The third problem is take home generally, but we will just. I have given the link. Okay, if it is a take home problem, let it be. I wanted for you guys to code yourself, but we will see the concept of it. We will discuss the question, and we will again just see some technical aspects which will help you code. That's all. I'm not going to give you the whole code just like this. You need to code yourself, but we will see in what terms it is similar to the previous problem and the concept of backtracking, how it is working. That's all. Okay. All right. Again, we'll discuss. Okay. Take 2 minutes. Read the problem very carefully. Then I would like if you in the comments only give just write something what you understood from like in the problem what you have to do. If you understood the problem, just write the very comment. I have understood the problem and it is what it is, the problem is asking for. I'm giving you 2 minutes and I'm also taking a 2 minute break. Just for now. Till 26. Have you read the question? Prateek, Poonam, and Srinivas. There are more people. I don't know why they are not responding. But big thanks to you guys. You are making this chat interactive and easier for the other people to respond as well. All right. Okay, what does it mean? I'll take the question over. I'll explain. Right? Great, Pratik. That is what we are going to do. Okay, and I'm going to illustrate it in a better manner. People might not just get it from illustrating it. I just illustrate the same thing, draw it for you, explain it to you guys. Okay. I'm waiting for the third person. Where is Srinivas gone? No. Let me present my screen. Guys. Yeah, all right. Is my screen again visible to you guys? Yes. All right. So what happens in n queen is you are given just a single value n. Okay, and that assume you have n to be 4. It is a good example to teach. Okay, people understand this smaller value. It is not very small. It is not very big. Okay, so if we take n as 4, what do we actually mean by it? The n is size of your chessboard. Chessboard. Okay. So when 4 is given, that means we are talking about a chessboard of 4 cross 4. Okay. We need to work upon this 4 cross 4 chessboard. All right. What do we have to do? This is a n queen problem. N queen problem. N means the size of the chessboard. We have to place n queens. That means if the size is 4, we need to place 4 queens such that no queen is cancelling one another. Okay. Anybody who plays chess knows how a queen moves. Assuming this is a queen where it is standing, what could be the possible paths the queen may take? It is this complete horizontal line, right? It is this complete horizontal line. A queen can move like this. A queen can move like that. Yeah, good, Srinivas. All right. So we have, I'm telling you about the parts. This is the whole row, and queen covers it all. It can move in these directions. It can move in these direction. It can also go in horizontal directions. That means that is covered, that is covered, that is covered, and that is covered. Okay. This is how a queen can move. All right. Now still you can see there are 3 possible ways. This one, this one, this one, and this one. Right. These are the ways. These are the places that this queen cannot cancel. Correct. I've just taken a random example. So we need to see that we are placing queens, n queens specifically for this problem, 4 queens, such that we are following this order. That means no queen is cancelling one another. If any other queens come in the path of this queen, that means that queen will be cancelled. Okay, we don't want that. All right, and let's do the let's for the question. What is going to be the approach? All right. So let's first do it with human intuition. Okay, how we are going to do it, and that human intuition is what we are going to be coding. Okay, I won't code it completely. I just give you the glimpse of it, and you have to do it. But you need to focus on what intuition you are having. All right, and only that intuition is then put on the form of a code. Okay, so assuming we are here, so let me just mark a star here. That means the queen is standing here. We have made our first choice. All right. We have to place n queens. We know that, and that would be only possible if each row here has one queen. Right. We need to make that clear in our mind. That each row here has one queen. Only that will be a possible way we can adjust n queens in this n cross n matrix. or you can say the chessboard, right? So if we are standing here, if we have placed the queen here, that means all the further options are not considered. In this row, all these cells won't be considered because this queen will cancel them. So the moment you have placed a queen in one of the rows, you will jump to the next row. Okay, you will jump to the next row. You will see that if this place is valid or not, or is safe or not. Is this safe? No. The queen above will cancel it. Okay. Is this block safe? No. The queen above will cancel this as well. So we will make up our decision here because this is a safe place, right? This is a safe place. Now, do we need to travel this block? Do we need to go further? We actually don't because we have placed one queen. That means the work of this row is done. Now we'll jump to the next row. We will jump here. Again, we'll see. Is this a safe way? We will stand here. We will look in this direction. When we are looking in the vertical direction, we will see I can see a queen there. That means this is not a good place to place the another queen. Else it will get cancelled. So we'll avoid this. We won't take this place. We will come here. We will again check the possibility. Okay, no queen is there in this direction. I can see up. No queen is there. I can now I can see in this direction, in this diagonal direction as well. I am unable to see any queen here in this direction. But when it comes to this direction, yes, a queen is there. That means this place is not safe. This place is not safe. We have to avoid that. Can we place it here? No, because it is directly up here. The queen is here. Can we place it here? No, because in this direction, this queen will cancel our new queen. That means in this row, no queen can be placed. If we meet such situation that we have, okay, if these are the ith indexes, if we have come so far that we are at a point that no queen is being placed and we are not yet out of the matrix. That means there is still one row left that in that row no queen can be placed. That means we have made wrong decisions. We have made wrong decisions. Now come the main point of backtracking. What is the point of backtracking? We make some decisions, we trust them, we go to the we make further calls, and in a hope that we'll be reaching the solution. If we are disappointed, that means we do not get any solution. We are going to backtrack. We are going to again come to a place where we have made a wrong choice, and then we will make any other choice and we will proceed with it. So here, what we will do, we will backtrack. That this was not the right decision. So we'll again go back to the second row. We'll again go back from the from the second row to the first row. We will not keep this queen here in this, but we will keep this queen here in the last one. We will again go on and look for this third row. We won't be able to place it here. We will be able to place it here. This will be safe, but we cannot place it. We cannot place here. Then we go to the last row. This is unsafe. This is unsafe. This is unsafe, and this is unsafe. That means third won't be filled. That means this is also a wrong choice. Okay, this is also a wrong choice. Let me just place it. That means first row is over. We have no further choices to make in the first row, so we'll go back to the 0th row. The very first decision that we made. That means this decision was wrong. We are going to cancel it, and we make another decision. We will make another decision. From here, we will again proceed to the next row. Once a queen is placed in one row, we'll go to the next row. What we'll do, we'll simply check this position. Not possible, not possible, not possible, possible. Placed. We'll go to this row. This place is possible. Yes, this is. I'll simply put it here. Yep, I got my queen placed. Going to the third one. Not possible. Not possible. This one here is also not possible. This place is possible, right? So what we have done, when we made this decision, we were able to accomplish this solution. Now we have successfully placed n queens in an n cross n chess. Okay, have you understood it till now? The people who knew how it is done, have they gotten a clear understanding of the illustration? And for the people who are already who are learning it for the first time, is this concept clear to you? Is the concept of this question clear to you? Everywhere in the chats, please write it. If it is clear, just write +1 or y. Prateek, Srinivas, Poonam. Srinivas, I got a response from him. Okay. All right, people, do you have any question till now? Any query till now? Do you guys like any concept or in general anything about backtracking whatsoever we have covered in this video? Anything? I'm going to explain it a little more. Then we are going to just have a little Q&A, and I'll talk with you guys and we end the session. Don't worry, we have extended it maybe more. You can say there is a way you can add up n points. Okay, for every n cross n chessboard, there is going to be at least one. Well, obviously there are more than one because if you talk about a mirror image, that is a straight second solution. There could be other choices as well. So yes, there are more than one solution, and for every n, there is one solution possibility. But if you talk about the base condition, then it contradicts. Let's talk about that. And so putting it up. If we talk about n equals 2, that means you have this small chessboard. Now this is small chessboard. If you place a queen here, okay here, then it cancels all the three positions. This is not possible. If n is equals to 3 as well, and try it on. N is equals to 3 crossing. Place a queen here, that means it has cancelled this. Okay, and you place your another queen here for the second row. This is a safe one. It cancel all these. You won't have any possibility of putting a queen on the third row. So for n 1, 2, 3, these are very small chessboards, and in this queens cannot be placed. Apart from that, when it goes, when we increase the value of n, the board is big enough, and then there are possibilities in which we can place this. All right. Yes. Okay. I hope that answered your question, Pratik. Okay. So what you have to do here, let's talk about with the perspective of writing a code. Assuming you are here in this chessboard, you have to think of it in a DFS way. Okay. Again, make up directions. Directions are very useful and utility that you can make for every of a DFS problem. It really makes the code very easier to read as well as to understand. You can okay, you can do something. Pratik, yes, these questions are the core and the classic questions which enables the interviewer to get that if you understand backtracking to the roots or not. These are the questions which might seem intensive to you, but these are intensive because I am teaching you with all the illustrations. Once all these illustrations are in your head, you can write a code straight ahead. Okay, just you can jump directly into the code and you can write it once all these illustrations, all these drawings are in your head. Okay, coding is half typing and half working on pen and paper and making drawings. That is what I always say. So if you are good with the diagrams, if you are having a clear understanding of what is happening, yes, you won't take much time of it. These might feel intensive right now because we are taking each and every aspect of it and we are explaining. Okay. In short, yes, these are asked. These are asked by names. They won't even give you a problem statement and they'll ask if you know NP or if you know rat elements or even a little modification of rat maze. Sometimes in interviews they also say solve a rat maze, but you have this restriction. Okay, so you must know how a normal rat in a maze is solved. Then whatsoever modification they are given, you have to optimize your approach according to that, and you have to present the solution. This is just to test how well you are able to create projects. Okay, all right. Uh, yeah. I was saying directions. You can make up a directions. One thing more, one useful thing. Because we are in this logic that I have given to you, in this logic, we are filling up the queens from this top to the end, right? From top to the end, we are filling up the queens. And notice in mind, whenever you are placing any queen, a queen is placed, you need not to go further. You are going to use a for loop for traversing this way, and we'll be making calls for every other row. Okay? This won't be a very hard problem once you understand it. Okay, these are classic problems, and these does not take more than 15 to 20 minutes to code. And even if you mess up, just let's say you'll take 15 minutes more debug. That's all. Okay, yeah. Coming back to the code, uh, coming back to the explanation of the possible code that you are going to write from the top to the end. We are coming this way. We are making calls, and we are making calls for each and every new row. And inside every call, we are going to be using a for loop to traverse in this direction. Change the color of my yeah. Okay. For you're going to be going in this direction inside every call using a for loop. And once you have placed a queen, that means you need not to go on further exploring this way. You can make another call instantly. When you make this call, that means again the cycle goes on. You need to check for every column if it is possible. If it is possible for you to mark your queen here. A hint to you guys, you need to construct a function. This could be is valid or is safe, name it anything. That will check that if a particular position is safe for a queen to stand or not. What it will check? It will check, okay, assuming I'm checking about, I'm checking for this block. Okay, I'm checking for this block. What I'm going to check, if this vertical is empty, if all these parts are empty, because if any queen is lying here, that means this is not a possible path. Another queen will cancel me. If this direction, we need to check in this direction. If this is empty, then we need to check that is this direction empty. Okay, what how we are going to achieve this direction? We already know about four direction traversal, down, left, right, up. We know about that, but how we can go to these diagonals? For this diagonal, what we are doing, we are reducing the column as well as the row. This is minus one comma minus one. All right, for your direction array. This is your, we are increasing the column and we are decreasing the row, minus one comma one. All right, this is how it is happening. This is how you will reach to that, and you will keep on doing minus one comma minus one, minus one comma minus one until you are out of the bound. You can again create one more utility function to checking if your current indexes are out of the bound. If this happens, that means if you have reached the end and you have encountered no queen, that means this path is safe. And if this is done with all these three directions, that means this is a path where you can put up your queen. Where you can put up your queen. This path. All right. This cell. This is how you're going to check. Okay. Now we are not. Why we are not checking the other direction? Because if we are in this row, that means we have already checked for these two and have not placed the queen here. That is why we are standing on this third one. Had we placed any queen here, what we would have done, we would have jumped to the next row. Okay, मतलब ही नहीं होता आगे आने का. But we are here. That means no, like no in previous direction, no queen is placed. So further, we are not going to place any. horizontally. I'm talking about this row, the second row. Further, we are not going to place it. We will directly jump to the third one. Okay, now why we are not considering these direction towards down? Why not these diagonals? Why not checking here? Because we are filling the queens through, like with this logic that I've told you. With this logic, we are filling up the queens from top to end. So if we are going further, like there is no means of checking further because we have not yet filled any queen there. That is the safest place. Okay, I hope I was well enough to make you guys understand this concept. And you guys have a little clarity in your head what I have told you till now. We can say with blueprint. With this blueprint, whatsoever illustrations I've made, is that clear to you? Quickly write that up in the chats, please, if that is clear. All right, thanks, Poonam. Everybody else, we have still 10 people watching. All right, thanks. Thanks, Pratik. Okay, so now I'm gonna stop sharing the screen. Okay, and now we can chat a little, and then I'll end up the stream. All right. So, people, how was today's session? How was today's session? Did you guys understand it? Did it meet its motive as per you? We were here to start with backtracking. Was that possible with you guys? We'll be chatting a little bit. You can put up your doubts in the meanwhile. I am here to take that. Okay. And for the homework, don't forget to do this problem on your own. All right. Just give it a try. And if there is any problem, we are going to have several of the lectures there. You can put up there, or you can even reach me on LinkedIn if I'm able to help you personally there. I will. No problem with that. All right. Thanks, Srinivas. You're saying that session was well. Uh, and good. Thank you, Pradeep. Thank you, Poonam. And I don't know, there has been constant watching of more than three of you guys, but nobody else has responded. Thanks for special thanks for Srinivas, Pratik, and Poonam for being constantly throughout the session here and helping me out to teach in a better way because you guys have made it interesting. Then the thing is, just for covering the wider audience, we prefer doing it in English. But if you would have asked me at any point of solution where you were unable to understand, I would have switched to Hindi as well. There was no problem. And during the session, wherever you are not able to understand any of the thing, you can put up your statement there. I was constantly asking for chats. You can put you may have put up your chats, and you have asked me to explain it again in Hindi. From the next time, keep it in mind, and wherever you do not understand anything, you can ping me up. All right. So it was great having a session like this with you guys, and I hope I was able to help you out. And now I'd be ending this stream. Before that, just for 1 minute more, I'd be taking the questions and would be chatting to you guys. You want to ask anything here related to today's session or anything in general, anything related to coding or geeks for geeks? One thing more, this is a habit builder 21 days that we are having. So I hope whosoever is following it constantly and with dedication, I hope you guys are getting results because it is meant for you guys to, get a knack of it and be better in coding. Right? I hope we are able to meet the target. Okay, so I think this is up for every person who are watching it after this stream. After this stream ends, I really would want if you enjoyed the session. Uh, yes, then I can speak in Hindi as well. How systems I post review. One of you can directly see the course reviews on the website itself, but the course that we give of system design is taught by a very experienced people, and those are good courses. Okay, and Zan, ठीक है, अब मैं थोड़ी देर हिंदी में बोल देता हूँ. So for everyone जो बाद में stream को देख रहे हैं, please if you like this stream, तो एक like drop कर देना, जो भी comment हो आपको, if you understand it well, if you understood it well, comment वहाँ पे डाल देना. And we'll be back tomorrow with a new session with new questions. Till then, ये question homework वाला please लगा दीजिएगा, and we'll be meeting tomorrow. All right. See ya. Bye, people. Probably my interviews. See, those are personally I don't consider that enough, but some people have curated those problems, keeping in mind some of the interviews, right? So for that perspective, that might be enough. But personally, I think just 75 problems are not enough, because if I even think about all the topics of DSA, all the topics, I mean all the readily asked topics in interviews, and for each topic, if I even consider five classical question of that topic, I would I don't think that would be sufficient. Like 75 would be a number that would end those questions. It would easily go up to 120 to 150 if I just take 3 to 5 problems of each topic, right? I hope you understand the thing. All right. So should we end this stream? What do you guys say? All right. You can write a bye, and I'd be leaving. Yep. As Srinivas said. All right. I'd be leaving. Bye, guys. It was nice being with you guys here. Meet you tomorrow. Bye bye.